Hello and welcome to the informational webinar for the WERC Environmental Design Contest. I'm Ginger Scarborough, the Program Manager. We're coming to you from sunny, mountainous Las Cruces, New Mexico, to help you get ready for the April contest. The contest is designed to be a project-based workforce development initiative. Our tasks are designed by industry and government agency professionals. Students pose as engineers as they solve real-world environmental problems. The problems require innovative solutions, and the teams build working bench scale demonstrations that they bring to the contest as proof of concept for their design. When they come, they're mentored by practicing engineers who are our judges, and they also experience a water-scarce environment. The contest was started 33 years ago, and your participation shaped a student's career and how industry gets involved in the contest, and some things from faculty who bring winning teams, how their students benefit, why it's worth traveling to Las Cruces to compete, how they gather and fund teams, and how they help their teams become winners. First, we'll hear from Mike Hightower. He is the WERC Design Contest lead judge, and he was on the founding board of WERC 33 years ago. Michael Jane from the EPA Office of Research and Development and a previous WERC competitor when he was a student. James Pleasant II, who represents El Paso Electric Company, one of our premier sponsors. And then three faculty members, John Pardew from Louisiana State University, Darren Ridgway from Ohio University, and Matt Bernards from University of Idaho. Now we'd like to hear from Mike Hightower.
Well, good afternoon, everyone. Let's see, I've got my obligatory WERC Design Contest shirt on. I've been involved with the WERC Design Contest since about 1995 and helped develop the major directions for the contest. And I just have a couple of slides that I'd like to show to kind of give you an overview of the thinking back in 1995. It set the context for the direction of the contest and what we tried to do. So a little bit about the philosophy, our intent to do student development and maybe student benefits. It's really based upon what we would call an RFP solicitation in the real world. So it's not a science fair where everybody does their own project. We identify essentially an RFP that comes out. The students will look at the task statements and look for a solution, and it's expected to address most of the engineering issues: viability, cost, performance, public acceptance, schedules. And then in a real world, on an RFP, if RFP solicitation likes what you want, they actually ask you to do a demonstration, do a bench scale, come and present, write a paper on your results. And then if it's successful, hopefully they work with you to implement that and work with industry. So what we tried to do is in this contest is mirror that engineering approach for developing projects. And so what we look at is developing tasks that are realistic, several different tasks and tracks, from environmental to remediation to biologically based. Some of them are public health and environmental health based tasks. You get to choose which one you might be interested in. Most of the times the contest has about 100 to 120 students. There's generally 5 or 6 tasks, and most of the teams have anywhere from 4 to 6 people on the task team. We have about 50 judges then that come and meet and judge the work. These are all professionals from engineering, health and safety, public acceptance, environmental groups that provide judges. So the students get the chance to interact with actual professionals in their career choice. And then the awards for each task. This is not one of those places where you get an award for participation. We do have first and second places. We have special awards. Here's just a picture of some of the teams at a recent design contest. Very similar to what you would do on an RFP. You get together, you work within your universities. They look at the research that's going on, new ideas, things that they might want to include, collect team members to get the right size teams in the right different disciplines. They start collecting their information. Then they start crafting a bench scale they can take to the design contest and demonstrate their project, their approach that they've selected. As a typical RFP, you oftentimes give a technical presentation of your results. So this is an example. Everybody comes, they get dressed up. They probably, all of them have a lot of new clothes because they haven't been dressed up for 4 or 5 years going to college, but they come, they give a professional presentation. They talk about their costs, their results, public outreach that they've done. the reason that their technology should be selected. And then they demonstrate their bench skills. The judges grade them on their oral presentations, their paper presentations. They go around and look at the quality of their bench scale. They're provided material to test and treat on their bench scale at the design contest. And we collect that data and measure that data to see that they're meeting the capabilities that they identified in their papers. And then we have poster sessions and have the students, just like you would in a regular technical presentation, where you can give poster presentations, you can have the public come by and look at your process. So we try to emulate an RFP professional environment in this contest. And the focus, again, is cost, performance, scheduling, public acceptance, the fact that the judges are there to work with the students to try to provide input on things that we think would help them in their career as they move forward. So the background of the contest was in 1995, as we were changing in DOD and DOE into environmental cleanup, there were no professionals that had this kind of experience. And so we spent a lot of time at WERC trying to develop classes and approaches for students to learn about these issues, come out of college with these kind of technical skills. And what we found is that this design contest kind of puts all of that together and allows those students to fast track that so that when they hit the ground after they graduate, they understand exactly what's required of them from an environmental perspective and a public acceptance perspective of their work. So with that, Ginger, I think that's a good overview for me, and I think we can go to other people.
Thank you so much, Mike. And every field of engineering needs to understand how to address environmental issues. We did have a question. What is the year level of students? Are they seniors or younger?
In general, they're generally juniors and seniors. We have seen some sophomores that find a project that they're very interested in, and they'll join in. I always think that it's good to have a mix of juniors and seniors, because if they really do well and they like it, you've got a management group that can, with some experience, that can help them in following years. I've seen many schools that have come in the first year, did not do very well. We got with them and talked about some of their deficiencies. And second and third years, they've come and done very well because they've had students that could continue to help out. I'm sure they have a couple of professors and faculty on this call that can kind of mention the benefits of having undergraduates. I will tell you that not only have we seen positive things if you have undergraduates, sophomores, and juniors, but bringing in people from other technical disciplines, business, health and safety, and things like that actually build teams that are very, very competitive in the process because of the number of different aspects of an environmental problem that need to be addressed. So anyway.
Okay, thank you so much, Mike. And I know that there are some universities that bring students in as sophomores, and they're in a team of sophomores, juniors, and seniors, and then they move up as they go along and increase in their responsibility as they go along. We are accepting teams through March 2023. And another question is about raising funds for the contest. And we will address that when the faculty speak later on today. Next, we'd like to hear from Michael Jane from the EPA Office of Research and Development.
Yeah, thanks, Ginger. Hi, everyone. I'm Michael Jane. I am with the EPA Office of Research and Development in Cincinnati. I've had various roles in this contest over the years, and I'll start from the beginning. When I was an undergraduate environmental engineering student at Clarkson University in Potsdam, New York, our senior capstone project was part of the WERC contest. And so at the time, our challenge was to design a zero waste semiconductor manufacturing facility. And so we had to take all different waste streams that were being generated by this facility and then figure out a way to beneficially reuse all of those different waste streams. And like Mike said, it really is interdisciplinary. So we have to do with air emissions, solid waste, liquid waste, all these different types of waste streams, and how can we use them, not just discharge them safely, but how can we reuse them in a beneficial way? And so a really complex, real world problem. Lots of complexity, many late nights we spent trying to figure out our solutions. We were very much invested in figuring out how to actually do this. And we were excited about the challenge of doing something like this that really did seem almost insurmountable at the time as a student. But we figured out how to do all of them, and we did end up winning first place in the competition, which I have to say. A couple of my observations from being a student participant, my first observation about the contest was really getting the opportunity to travel down to New Mexico State was a great opportunity for me. I'm from the Northeast originally. I'd never been to the desert Southwest before. And so just being out there, experiencing that environment and understanding about the water scarcity issues and, getting to see the mountains and the white sands and all that was really, that part of the trip was actually really beneficial to me, just in terms of getting exposure to new places and new ways of thinking. In terms of the contest itself, what really struck me was the fact that we were presenting our solutions to Intel. And so Intel was there judging the contest. And, we really got the sense that they cared about our solutions and that they were going to take our ideas and build on them. Whether they actually did, I don't know. But we certainly got that impression. And that's something that I've now tried to replicate now I'm serving as a judge and task developer, is this opportunity to really engage with the students and talk about real world issues and really make them feel empowered, like their ideas are being taken seriously, which they are, because we present challenges that don't have solutions. And we were very interested to see what the students come up with, because oftentimes they have the ability to think out of the box in ways that maybe we don't after getting ingrained in our engineering minds for so long. And so it's really great to get the fresh ideas and see what they come up with. And now that I'm here at EPA, I've been working as a judge and a task developer. Last year, we co-sponsored a task on virus monitoring. And what was really cool about that task was that it actually, again, Mike said, these are structured like RFPs. And in that case, it actually, the challenge was very close to a national priorities grant that we had just announced that ended up being $6 million in funding across, I think, 5 or 6 different projects. So the students were really being tasked with the same problem that real world scientists and engineers were trying to solve for us, was the same problem that was presented to these student teams. And obviously a much different funding level, obviously level of rigor, but it was a complex problem. And it was really, really exciting to see that they understood what we were asking them to do, because again, it was this kind of obscure question about how do you monitor viruses during wastewater treatment. And they really came up with great solutions. All the teams were really impressive in what they came up with. They understood the constraints. They understood what we were trying to do. And they really had some good ideas that we've been able to kind of take back and think about. That to me is one of the major aspects of this particular contest that I think is a benefit, is that these are really our real world problems. They're not hypothetical, and they're focused on questions that we're trying to answer as industry, as government. We're trying to figure out solutions to these, and we can present those same complex problems to the students and see what they come up with. And then they have the opportunity to then interact with us and talk about all the cool things they figured out. And from my experience, the students really, really get a great benefit out of that, and they really enjoy having the opportunity to interact with the people who are posing the questions and really feel like they're contributing to a solution. But I'll stop there. And I'll pass on to the next person.
Thank you so much. Now we'll hear from James Pleasant from El Paso Electric Company.
All right, but good afternoon. My name is James Pleasant II. I'm an engineer and also project manager for the electrification of transportation within the Renewables and Emerging Technologies Department at El Paso Electric. And so here at El Paso Electric, we look to continue to drive for a greener and more sustainable future. That's the department we work in. And just to give kudos to the WERC environmental contest design, I took a part of it last year for the first time as a judge, and I had the pleasure of working with Michael Jane on the virus detection as well. And like he was saying earlier, it's just a great thing to get everybody together, all the different companies and the different perspectives of how it's important to our group versus their group, and about how the students can come up with a very innovative idea that's really going to be put into real life initiatives. And for our group in particular, we work with utility, which is electric utility, and especially when it comes to renewables and emerging technologies. And what we mean by that is distributed generation, which most people are familiar with, like solar, wind, hydro, etc., battery energy storage systems, electric vehicles even. And then what's also a new, very hot button out there is the distributed energy resource management systems, or DERMS for short. What I like to basically kind of sum it down to is the electric grid is used to the traditional model of we generate the power, we transmit it, and we distribute it to the customer. But now with all this new opportunities, the customer themselves can create this energy themselves. And of course, we all want to move towards a greener, sustainable future. There are some challenges that need to be overcome. And so when it comes to these contests, we would love for these students to help us out with our goals of the best implementation of these emerging technologies. One thing that we want to highlight too, that when we come up with these tasks, not only think of it from the vendor side of things as the utility, but also think of it as the customer side. And of course, being in an environmental contest, we want to see how is this going to impact the environment, with the least negative impact as possible. Thank you for your time, guys. I'm going to go ahead and pass it over to the next speaker.
Thank you so much, James. Now we'll hear from John Pardew.
Thank you, Ginger. My name is John Pardew. I'm a professor of civil and environmental engineering at Louisiana State University. We've been a long-time participant in the WERC contest for over 20 years. of the 33 years of its existence. And I wanted to give you a little bit of perspective as a program coordinator as to why we continue to come back. What we see with our students as we're launching them out into the world is that it's very difficult to replicate what the contest gives our seniors. And it gives them an ability to not only interact with environmental engineering students and chemical engineering students and civil engineering students from all over the United States, but also puts them face to face with this remarkable group of judges that not only looks at their solutions and gives them positive or negative feedback, but does it in a positive way that builds capacity, builds confidence, regardless of whether they win or lose. And so for us, it became such an obvious selling point and strength that the students love the experience that we've really built a lot of our senior year around participation in the contest. Why we do that is that it checks just a lot of boxes for us as a program. We've again been ABET accredited since about 1998. We've produced over 500 students. We produce anywhere between 25 and 50 seniors a year. And so we can go to the contest and get these really industry written tasks with real constraints that we don't have to write ourselves. They're written for us. This competition has been around for 30 plus years. It's well organized. I don't have to go there and worry about, is the food going to show up? Are the judges going to show up? All those things. Everything is extremely well run, and they charge a really fair price for what they provide for the students. It's really scalable to any size student group. I brought 6 people before, and I brought 46 people before. I can scale it to any size student group that I have that I want to bring. If you have things that you're already working on in your lab, or things that are important for your region, or things that are important for your campus, as we've seen the last couple of years with a team from UT Chattanooga, you can fit into an open task. This year, task 7, you're bringing an engineering design that is important for your location. It doesn't all have to be things that are written in the task from industry. I brought New Orleans stormwater projects, or I brought air pollution projects that were relative to my state, that the judges work with us to evaluate those and provided amazing feedback. So regardless of how you run your capstone program, there are things that fit into the work design contest. We use a lot of it for ABET. It fits well within an ABET outcome assessment structure. We've gone through 2 different cycles in the last 14 years where accreditors have come to campus, and they have loved the work contest involvement. And we try to send every student that comes through the program. That's not always possible, but we've only lost just a couple of students that haven't been able to participate, and they love it. The ABET is extremely high on this as a way to assess the outcomes that are in your A through K ABET assessment. If you're an assistant professor, an associate professor, full professor, you're going to learn a lot. You're going to stay current on some things in the industry that I or you didn't know about till you went. Michael just talked about the EPA project. I didn't know much about that till I started. We had a team that did that. I learned an awful lot about that. And I'm involved in some things down that alley in my lab now because I was able to learn a lot from doing that project. And it's fun. The time that you spend there is a blast. I asked my students to raise $850 for a plane ticket that covers their hotel, that covers their food outside of what's provided by the contest. And then the remainder of the few thousand that I need for registration, other things I can get from my dean, my department chair, or I can raise that from industry. And so students, in some cases, get money from their parents or grandparents. They, in some cases, get money from internships that they're running and do it from there. When I go, the last thing I'll say is it really clarifies my role as a capstone coordinator. I'm not the judge and the mentor. I'm not the grader. I'm just the coach. I can go there and I can stand at this vantage point that you see here on the screen. I can watch them talk to the judges, and I can only be a coach. That's all I have to do. After this set of judges leaves, I swoop in, I find out what the questions were. I ask them to give me any questions, what their thoughts are, or any things they missed that they could improve on the next thing. And it really clarifies my role completely. The judges can be the judges. I can be the coach. And that makes things so much easier than trying to be the coach and the grader at both times. And you see here kind of the situation where you have winners in some cases, where on that Wednesday night, we go to an award ceremony and some of the teams win, some of the teams don't. And as you're driving back to the hotel that night with some winners and some losers, that's about as real as it gets in environmental education or undergraduate education. You know, you celebrate with those that were all in on their project and were successful, and it's something they'll remember the rest of their lives. And then those who weren't successful, you got to draw some lessons from that. And I think they're both equally valuable to the students, to be honest. I mean, that's a flip kind of a statement. I'd prefer them all to win, but I do think that I see a lot of growth in the teams as well that didn't win and move out of there. So did I mention it's fun? Karaoke or hiking or white sands or great restaurants in Old Town Mesilla. It's a very inexpensive place to visit. It's a water scarce environment with a lot of great people, and we just love it. We're going to continue to come as long as they'll have us, and we hope that you'll consider joining as well. Thanks so much, Ginger.
Thank you so much, John. Oh, and he shows a picture of his students playing at White Sands, which is only about less than an hour drive away, about 45 minutes.
Right.
You mentioned that sometimes you bring over 40 students. We did have a question in the chat. It says, I assume multiple teams can participate from one university. So when you have all these students, it's in smaller teams. Like last time you brought 6 teams?
Yeah, I like to do 6 to 7 students per team. I think 4 is too small. I like to have in the 5, 6 to 7 range where I can really get all of them engaged. They're not too big, they're not too small where you're missing some aspects. And so, yeah, we can compete. I don't like really them competing against each other. That happened this year where I had multiple teams who wanted to do, for example, the carbon capture task. And I let them self-select. I really think that they're going to spend this time doing this for a year. They ought to be able to pick what they're working on. I allow them to pick 2 friends that they'd like to have on their team. And I also anonymously allow them to pick one person they prefer not to have on their team. And then I make the teams. And generally it works out. You know, they're not all buddies and they learn each other. And obviously they get very tight. There are conflicts that have to be managed, but I think that the teamwork aspect of it is a great experience as well. And the judges are just so good at working with that. If there are problems, they point that out to me in their comments that I can use for the next year. And if they obviously are working together, that gives me great joy to see that the team has come together and seen that. So we encourage you to come.
Great, thank you. And he simultaneously, while there was a question put in the chat, you answered it without knowing it when they asked, do you let groups choose which track they're going to or which task they'll work on? And you said that you do because they're going to be working on it for a long time. They are.
Yeah, I do. And not everybody gets exactly what they want. And sometimes I ask them, would you prefer to be in a group with this person who you maybe didn't want to work with? And a lot of times they'll self-select into another group if that's real important for them. But I don't have a lot of people moving around. Generally in September, these things are set and they don't really move around much. So
sounds great. Thank you so much, John. Now we'll hear from Darren Bridges from Ohio University.
Hi, this is probably a good follow-up to John's because we do the contest a little bit different than he does. We've been doing this for 20 years. We missed a couple years in there. I've been doing it most of those years. So for me, I added this up yesterday. We had 228 different students have done this. A few have done it more than once, the majority one time. Historically, we've had from 1 to 4 teams. Now I lost my co-worker who was helping me. I usually will try to run 1 to 2 teams. That's about what I find I can do. And I agree with John on the team size. I like to try to keep them around 6 or 7. Everyone can participate. I've run teams as small as 4, and he's right. That's kind of on the edge of being able to get everything done that needs to be done. So the difference here is this is a voluntary activity at my university. We do not use this as their senior design project. The way we structure our senior design project here and what we're trying to hit in terms of our curriculum and stuff, we just can't guarantee the tasks have all those features. So we don't use it that way. I do give the students 2 hours of technical elective credit, which they can count toward their degree. They have a requirement in that area, but I officially run it as a by permission class. I have to let them in. They fill out a little application for me of how busy they are. How many classes are they going to have? Are they working outside of class? And so just make sure they have the time to participate. I'm not cutting people based on GPA or anything. I do let them in, but it's not really hard to get in. Funding. I find that the whole budget of everything for me ends up running about $1,100 to $1,200 a person. Almost all that's in travel. So I usually end up only having about 1,000 to 2,000 maybe in our budget for the bench scale construction and stuff. Sometimes that affects which tasks we do, that we need to make sure we have the money to do it. We're not going to be able to go out and buy an expensive piece of equipment or anything. I don't have the students pay. That's an internal thing that I'm not allowed to have course fees at my university, and I can't make people donate. And so we basically go with the students don't pay. They do have to pay for their own meals and stuff on the trip that aren't provided, but I don't have them pay anything. I can get up to 50% of my budget, up to $5,000 max from my college. They have a nice student activity fund I can use. The department has some funds, again, mostly donated by alums and stuff that we use on this. I occasionally have an industrial sponsor. That's pretty sporadic. If it happens, it often happens from one of the students participating goes to the company that they co-opt for the previous summer or something and gets their boss there to throw us a little money. If we win any prize money, the prize money is generous and we put that right back into the pot and use it the next year. And then right now I have a little bit of a unique situation that I had a really large group for me 2 years ago. We were way short on money. They raised a bunch of money, about $8,000, sort of a GoFundMe type of thing. A lot of it came from my WERC alumni, those 228 people. But because we ended up not traveling that year in 2020, that pandemic year, I still have that money that they raised. So that's my current pot of money. But again, $1,100 to $1,200 per person is what I can do this on. We typically make this a week-long experience. We'll travel from like Saturday to Saturday would be typical, a couple travel days in there. We do the competition, and then the last 10 to 15 years, we make the haul and I take my students to the Grand Canyon and they do hike around the canyon for a day. This is a big selling point to my students, is the trip. As it was one of the earlier speakers said, most of them have never been out west. So this is a big deal. This is a big adventure for them. And so the trip itself is a big selling point. Again, you've heard a lot of this. I say don't get discouraged in your first couple of years. Your experience really helps. The first year we went, we had 4 teams and we had the lowest score in every task in every scoring category. And now we've managed to be reasonably successful. I use my alumni to help the teams. And I'm not talking about the auditors, which is probably a term you don't know, an official step, but I hook my teams up with people that can actually help them, especially in areas that I'm weak in, like legal and regulatory issues is not my area. I have alumni that work in this area, and I just hook the teams up with them and have them communicate with them. And this is good for their project. It's good for them professionally to have to deal with these people. And so I use my alumni network to help me a lot. I just say I get a lot of comments like, John, this activity, that it's one of their highlights. They mention how frequently participating in this comes up during their job interviews, and they could use it in the job interview quite a bit. So I'm going to stop there and I'll answer any questions.
Thank you so much. We don't have any questions in the Q&A right now, so we'll hear from Matt Bernards.
Hello, everybody. My name is Matt Bernards, and I am faculty in the Department of Chemical and Biological Engineering at the University of Idaho. And we come at this project with some overlap to some of the things we've already heard from the other faculty mentors. This is part of our senior capstone design, but it is only one of the project options that we present to our students. But fortunately, the students and the alumni in the department really hold this competition in high regards, and it's a point of pride to be selected for the work competition team. So inevitably, we always have a group of students who are very passionate about participating. I've been at the University of Idaho for only 6 years now, but our department history with the competition goes all the way back to the beginning. And I think we've participated as a university in greater than 30 of the 32 or 33 work competitions. And as a result, we have a trophy case in the hallway that all the alumni come back and look at that have trophies from all of the years where our teams have performed very well. In contrast to what you've already heard, we actually try to target a little bit smaller team sizes at the University of Idaho. We prefer teams of 3 or 4 students because we find that if our teams get too big, we start to have students who really aren't contributing towards the project activities, and it's easier for them to fall by the wayside and hide. And just as one example point, we did take home a first place prize this past competition with a team of only 3 students. And so if you have the right group of very highly motivated students, it is possible to do very well in these competitions, even if you don't have a large team of 6, 7, 8 students. In terms of how we fundraise, we go with the shotgun approach for raising funds for this competition. We have a tiny course fee associated with our senior capstone design that comes nowhere near covering even the bench scale costs. We, depending on the year, do aggressive letter writing campaigns to alumni from the work competition for donations. We have done applications to our internal Office of Undergraduate Research if the particular task might align with some of the undergraduate or faculty co-mentors' research interests. And we have had strong support from a local industry in Idaho, Micron Technologies. And so I've been fortunate enough to have a nest egg from a prior donation from Micron to cover any years where we've struggled in the fundraising perspective. In terms of the value added from this competition, I think one value added component is the diversity of the project topics and the fact that almost all of them are sponsored by an industry collaborator, co-sponsor, et cetera. So it really gives the students the opportunity to see a variety of engineering challenges, but then find something that they're passionate about helping solve as part of their career. And so when we pick our teams, much like we've heard, I don't assign them a task. I don't assign them a team. I say, you're going to self-select teams and you're going to self-select the task, because if you're not passionate about participating in this competition, then the team itself is not going to do very well. One thing that we do that perhaps is a little bit different than some of the other teams that kind of builds on what we heard from Mike Hightower about this being learning like it's an RFP from an industry client. I always use our end of the fall semester as a go, no go point for the team. So they turn into me a status report of their accomplishments over the first semester. And I determine if it seems like they're on a good path where they will be able to fare well and show well at this competition. And if they are doing well, then we do the registration process. And for new teams, the early registration deadline is usually at the end of December. And fortunately, only once I've had a team that really seemed like they were struggling, they weren't meshing, and they weren't putting in the time and effort required. And so we did not attend the competition that year. So that's one of, I think, the 2 that we as a university have not attended. In terms of the activities, there are a number of very easy sites and tours and great restaurants that you can add on to your travel time. I always let the students self-select whether it's going to White Sands or doing a brewery tour of Las Cruces or doing some of the close hikes. So our activities vary from year to year, really depending on the interests of the student teams. And I think most of my other thoughts mirror what we've already heard. So I think I'll turn it back to Ginger for the Q&A session.
Thank you so much, Matt. We have about 1 minute left. There was one question in the Q&A that I can answer, and that was, if you do it as a capstone, do you do it as a 1 semester or a 2 semester? We have teams that participate both ways. Those who start as 1 semester, I recommend that they just get started informally to start doing some background research in the fall and then really get going. And that's what most teams do. They do their background research in the fall and then they get going building their bench scale in the spring. And so our time is up. Thank you so much for joining us. We can hold on a little bit longer if there are any questions. Otherwise, please contact us and we'd love to have you come. Someone asked us to talk about the registration process. Early bird registration has a discount, and we have links on the website for you to register your team. You can start registering anywhere starting in October, and early bird goes through end of December, and then there's the regular registration that goes through end of January, and the final registration is through the beginning of March. And we're in a little bit of state of flux as to the registration process, and we will be posting that online. I don't see any open questions right now. Please feel free to contact me at work@nmsu.edu or to call me at 646-8171. Thank you so much for joining us, and I hope that you can urge others to join us on August 10th. Thank you. Bye-bye.